The more detailed neural process of the high and low roads looks as following. Everything starts with a stimulus. When there is a visual stimulus, it is perceived by the retinas. The only light-sensitive cells in the retinas are the photoreceptors. So in the case of visual stimulus, after perceiving it, the signal goes from the photoreceptors of the retinas using the optic nerve axons to the lateral geniculate nucleus of the dorsal thalamus. It's 90% of the axons in the optic nerve. On their way, the optic nerves from both eyes meet and cross, forming the optic chiasm at the base of the hypothalamus of the brain. This allows the information coming from the both eyes to be combined and then split according to the visual field. After the optic chiasm, the left and right optic tracts delivers the information to the lateral geniculate nucleus of the thalamus. At this point, the thalamus doesn't know yet if the signal it is receiving has any association with the danger or not. However, since it is possible that there is a danger, there might be a burglar in the house, the thalamus forwards the information to the amygdala, the low road, just in case. On receiving the signal from the thalamus, amygdala sends a neuronal impulse to the hypothalamus to initiate the fight or flight response that could save your life if what you are seeing and hearing turns out to be a threat. Two major pathways, including the ventral amygdala-fugal pathway and the stria terminalis, connect the amygdala with the hypothalamus. On the other hand, the neurons in the lateral geniculate nucleus forward the signal to the primary visual cortex, which is located in the occipital lobe, where the processing of that information continues, the high road. This projection from the lateral geniculate nucleus of the dorsal thalamus to the primary visual cortex is called optic radiation. The visual cortex connects directly with the amygdala that through the hypothalamus triggers a response.